again. 3.5 is equivalent statements and variations of conditional statements. Two statements are equivalent if they have the same truth values, which means we're going to use truth tables to show that two statements are equivalent. I need to show that P or Q is equivalent to, if not P, then Q. So I will use a truth table, and I'm going to use my shorthand way to do the truth table just to save time and space here. So the P values are T, T, F, F. My Q values are T, F, T, F. And OR, we know for OR is false if both are false. So this is true, 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 false. Now let's do the table for this chart. This says not P, so look at your P column and negate those, which makes this false, false, true, true. The Q column is exactly what you see right there, true, false, true, false. I am doing the conditional, and we know the only time the conditional is false is if the premise is true and the conclusion is false. So this is false. The rest of these entries are true. So take a look at those two red columns and compare those. They are identical. And what that just proved is that P or Q is equivalent to if not P, then Q. What we just proved on the previous screen is that these two statements are equivalent. And it might seem odd to you that an or statement is equivalent to an if-then statement. So let's take a look at a compound statement here. I go to the beach, that'll be my P, or I go to the movies, that's my Q. That is equivalent to this. Now what this is an if-then, if something, then something. And it's if not P. So if no beach, I'm just abbreviating this, I'll write it neater in a minute. If no beach, then must have gone to the movies. So that looks a little better like this. If I didn't go to the beach, then I went to the movies. Now the reason this is equivalent is this. For an or statement to be true, one or the other statement must be true. So if I didn't go to the beach, we're saying, oops, that's not true. Then the Q part of the statement must be true. I didn't go to the beach, that's the negation of the P, means I must have gone to the movies. So this is another little statement that might be worthwhile writing down on your card because you could see it pop up here and there and it'll make things a little bit easier for you. So here's another one we want to show. We want to show that this and this are equivalent to this one. Now here's my beginning of the truth table with the P's and the Q's. So P is T, T, F, F. I need to do not Q, which is to take this column and flip-flop it. So false, true, false, true. And we are putting that together under the conditional. The conditional is false only when the premise is true and the conclusion is false. So this is false. Otherwise, these are all true. So this part in red is my result for just that part there. Let's go through these statements here. Not Q will be false, true, false, true. P just stays what it was, T, T, F, F. It is also a conditional. So the only time the conditional is false is when the premise is true and the conclusion is false, which is right there. So the rest of these must be true. So that's the answer for that little parenthesis. Now I need to put those two red columns together using the connective and. The only time an and statement is true is if the two simple statements are true. So true, true is going to give me a true. True, true will give me a true. Otherwise, it is false. So this here in black is my result for all of that truth table work. So let's look over here. P is T, T, F, F. Not Q will make this false, true, false, true. We are putting this together under the biconditional, and the biconditional is true if the two truth values match. So true, true gives me a true, and false, false gives me a true. These other ones are false. Now look at this compared to my result over here. They both say false, true, true, false. A little more complicated one because we have P, Q, and R. So let's fill in not P. That's going to flop all the P's around to be false, 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 true, 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 true. Q just stays what it was. T, T, F, F, T, T, F, F. Now not R means take all of those and flop them around. So it's going to go false, true, false, true, false, true, false, true. Now order of operations tells me I need to do what's inside parentheses first, so I'm dealing with this right here. Or, the only time an OR statement is false is if the only time an OR statement is false is if both simple statements are false. So this is false and this is false. Otherwise we have trues in this column. So this is my answer for the parentheses part. I need to put that together with this column using the conditional. So I'm looking at this with the blue, with the conditional. The conditional is false only when the premise is true and the conclusion is false. So I have a true followed by a false here. This will be false. Otherwise, the rest of these are true. All right, to do this one, starting inside the parentheses, R is this column here, which is T, F, T, F, T, F, T, F. Not Q tells me to negate this column, so this will go F, F, T, T, F, F, T, T. And I want to put these together under the connective AND. AND is true only if both the individual statements are true. So true, true will give me a true here. And true, true will give me a true here. Everything else in this column will have to be false. So I'm looking at this blue writing as my answer column for the parentheses. I will do the conditional with P, but let's write down the P, which is true, 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 false, 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 and I need to do the conditional between the blue and the red. The conditional is false only when the premise is true and the conclusion is false. So where does that happen? That happens right here, which means the rest of this column is true. This is a whole lot of work to show that two statements are equivalent. So now I need to look at the green on this truth table and compare it to my answer column, which was the black over here, and see if they are the same. So are those two the same? It's true everywhere except the false in the second last position. True everywhere except false in the second last position. So are these equivalent? The answer is yes.